Okay, so today we're going to talk about elevations in specific, and I'll talk you through how to draw elevations based on a floor plan, etc. And that'll be the technical side of things in AutoCAD today. But before I get into that, I thought it would be worth our time to talk about line weights, and specifically how line weights relate to elevations. Once again, on the back of your handout for today, I did include the standard line weights guide, just as a kind of a background thing to be thinking about. But we're going to talk about line weights in a little bit more detail today, and hopefully this will help emphasize the importance of line weights and why we spend our time doing line weights in the first place. When I talk about a line weight, I'm essentially referring to the relative thickness and or darkness of a particular line. And the thicker and darker a line is, the more it stands out in a drawing. The thinner and lighter a line is, the more it recedes into the background. So we as designers, we as architects, we as industrial designers can choose what we want somebody to be focused on in a drawing. We can also add depth and scale to a drawing based on these lines themselves. The basic graphic property here has an enormous effect on the overall drawing and how we perceive what's happening in 3 dimensions in that particular drawing, because we are representing a 3-dimensional object in a 2-dimensional plane. The range of line types that you can also add beyond the thickness or the relative darkness of a line, so a dashed line, for example, can give us yet more information. So this is a whole vocabulary that we can use, similar to a language. Here's a bunch of line styles. This was not something that I developed. This was something I found online, but I thought it was a pretty good summary of the various line styles. Solid lines are visible objects seen in plan section or elevation. Dashed lines or hidden lines show something that isn't actually there, but it's referencing it. So it could be something that's above, it could be something that's behind something else, and we show it as a dashed line. It's a very common, so between solid and dashed lines, those are kind of the 2 most common lines that you're going to see in an architectural drawing. Of movement or a phantom line, it's technically speaking, it's a line with 2 dashes and then another line. In practice, I don't see this used that often. I think it's usually just a thin line. This would be something like a door swing, for example. Usually doesn't have the breaks in it, though. Leader and annotation lines, these are notes pointing at something. They usually have an arrow on one end or a tick mark on one end. Break lines, these are those lines, you've seen these all before. Break lines are the ones that do this. And they show that something is bigger than what fits on the page. And so you might have some object, and then you have a pair of these lines next to each other, and it means that I shrunk that, or I cut something out such that I can fit more onto the page. It's very common to see it, and we'll see some examples of that a little bit later. Center lines indicate the center of something. Usually it's a circle or an arc or radius, something like that. Section lines are usually the boldest lines of any drawing, and they're usually something that's cut through. And so in a building elevation, like today, you'll see that the one thing that's cut through in a building elevation is typically the ground. And as a result, that's the biggest, thickest, heaviest, darkest line on the whole drawing. Dimension lines are showing dimensions of something. They're giving us a measurement, and they're usually fairly thin. Line weights are going to vary, and this is a lot like the chart that I showed you on the back of your handout today. Coincidentally, a lot of these match up fairly nicely to what I told you. Construction lines are the lightest lines that are going to be on your drawing. If you were drawing by hand, you would use a 6H or a 4H lead in your pencil. I guess it's not lead, it's graphite, but you guys get what I mean. To draw that line because it's really dark. It's going to be 0.00 in AutoCAD to 0.1 millimeters in thickness. Or if we were working in Illustrator, it would be 0.18 to 0.25 points. So this is telling us first little block, 6H to 4H, if we were drawing by hand. Second block here is if we were drawing in AutoCAD. Third block is if we were drawing in Illustrator. So it's giving you all 3 of those. Light lines, these are things like door swings, things that you're not trying to draw a lot of attention to. Those are going to be somewhere in the neighborhood of 0.10 millimeters, 0.09, 0.10, all the way up to maybe 0.18, something like that. Medium lines, these are things like doors and furniture, are objects that are in the scene. Those are all the way up to 0.2. I usually make them 0.18. If I remember correctly, that's what I told you guys last class. Bold lines, These are the big boundary objects. These are things like walls, etc. They're going to be even thicker. And then we get the cut lines. In the case of the elevation, that would be the ground. It's going to be from 0.4 on up. Sometimes you get up into 0.7, 0.8, something like that. So just running through those. So these lines have an enormous effect on how we perceive what's happening in a particular scene. And I think this is a really good slide for illustrating this purpose. So in each scenario, we are this little eyeball, and we're looking through this plane right here down at this thing that's happening, this scenario. And so in the first scenario, we have a flat plane and we have a little tiny groove that's happening in that line. I disagree a little bit with this drawing because I think there should be a second light line there. It's a technical detail. I didn't make this. And essentially what we have is we have the plane and we have a light little line that's showing up right there that's telling us this is happening in the plane. A little dip in the plane. When we move over to the next one, number 2 here, and we look down on it, we have a surface that is closer to us and a surface down here that's further away and one surface that slopes down. And so if we look at the line weights, the thickest lines are the ones up at the top, including the fold line. The next thickest lines are on either side as it goes away from us. And then the thinnest lines of all are the ones at the bottom plane, right there and right there. So we've regulated the lines to give us the sense of depth. Thickest lines closest to us, thinnest lines furthest away from us. When we move to the third example, number 3 here, that's a terrible 3, but you get the idea. In this scenario, we have one plane that's up here, straight drop to the second plane that's down below. In that case, the thickest lines are right there. Again, the piece that's closest to us, and the thinnest lines are down below. In this last scenario, number 4, the plane tucks underneath itself right there. And in that scenario, we're getting a different line type. We're getting that dashed line. Same in terms of thickness. What's on top is nice and bold. What's down below is nice and thin. But the dashed line is referencing the fact that the bottom folds underneath, as opposed to being inline or outbound from the upper plane. Here's another set of standard architectural lines. We have the section lines up top. These are indicators of where we're cutting a section or through the building. We have dimension lines. You can see they're nice and thin, as I said earlier. In this class, you guys won't be dealing with section lines or with dimension lines. We will cut sections when we work in SketchUp, but we're not going to do them in AutoCAD. Likewise, we're not going to work on dimension lines, so you're not going to see those. The break line was what I talked about with that little, it's kind of like a heart rate monitor if you were in the hospital. It's one of those little blips. That's the break line. Movement or a phantom line is a long line with 2 dashes. Like I said, I don't find that too common in practice. Center line is telling us where the center of something would be. The dashed line or the hidden line is really the most common. Solid and the dashed lines are the most common that we're going to see. And then the leader line or the leader line with an elbow just is giving us a little arrow on the end, pointing out something. It's like a note of what's going on. So here's an example of 4 sets of planes that intersect. And depending on which lines are bold, we can control which pieces come forward and which pieces recede. So if we looked at this without any bold lines on it, it would be hard to tell, well, what's in front and what's behind. But by putting thick or thin lines on, we can start to read what is in front and what is behind. For example, in this first one, we could tell that this here is coming toward us as it folds around. Likewise, this piece is again coming toward us and back, where these things are further away from us and behind. Same shape, we can change. This is now coming toward us there, and that's folding away from us. So it's a mental exercise to see what's in front and what's behind, but it's a good way of just using your line weights to show us some information. Let's move into the real elevations. And I start actually not with computer-generated elevations. The first couple I'm going to show you are hand drawings, because this is how originally elevations were done. This is a beautiful elevation drawn of a house, and we can see that there are a variety of line weights that are naturally used in this particular drawing. The thickest line, like I talked about, is where the ground was cut through. It's this line right here. It goes right along and up and along there. That big, thick, bold line is representing where the ground is. And so we can really easily see, oh, this building is partially on a hill. There's a little bit of something going on underneath, maybe a basement or something like that. And really, that's where the hill is. Okay, I understand this building now. So a couple other things that happen as we start to look at this. We can see the use of a hidden line right there. That's showing a little basement window that's kind of scooped out. So the ground is going above it, as we can see right here. Ground goes above it. This thing is hidden by the ground because it's a little scoop out that gives us access to that particular window. But we can also look at the line weights in some other context. If you look at the line weight that is right along this edge, right here with those shingles, and I know I'm covering it up, so I'm going to wipe it off here for a second. That line right there is a really thick, bold line. It's not as thick as the section, it's not as thick as the ground, but it's the thickest, it's the next thickest line. That, coupled with maybe the sides of this and the sides of that. That's because that's the next plane that we're seeing. It's the next thing that's closest to us. As we go further away, we get this set of objects. That's a little bit lighter drawn in. Likewise, if we move to the other side, the thickest line is right along this edge right there. And this is a little bit thinner as well. So this was all done naturally by hand, just using different thicknesses of lines, and it gives us that sense of depth and dimension. It's another example of a hand-drawn elevation. Same sorts of things that we're going to see. The thickest, boldest lines are the pieces that are closest to us, and the thinnest lines are the ones that are furthest away. The other thing that can happen with some of these, and I think this is a good example of it, is this particular architect was trying to tell you that this building was in the middle of some trees. And so you can see the squiggles that represent the trees along the sides and that sort of thing. They're a little bit dark, but they're shown empty as just little squiggles. And we can get a sense that these trees are there. Furthermore, if you look carefully, there's actually a tree right in the front that goes up. And you can see the top of that tree right here. I'm not going to trace over it, but it's if we follow it along, you can kind of trace it right there. I guess I will trace it. And that's showing you that it's in front of all of this. But it's lighter. So even though it's closer to us in this scenario, it's not something that the architect wants to emphasize. Therefore, it's a little bit thinner. So it's important to weigh the importance, not only how close something is and how far away it is. But the same thing exists. The things that are close, that edge, this edge here, those are nice and bold. This edge right there of this little piece that pops out, that's nice and bold. Same thing right in here, that edge and that edge. And as you recede back, as you step back in planes, we get thinner and lighter lines going back. Sometimes if you're struggling to see this, squint your eyes a little bit and look at it. Don't look at it really hard with your eyes open. Squint your eyes and look at it, and the darker pieces will tend to drop out for you. And you'll see which ones are standing forward. So we move from the hand-drawn into some of the more computer-drawn. So there's going to be a mix today of AutoCAD elevations and Revit elevations in these. Obviously, we're not covering Revit in this class, but this still gives us a pretty good sense of line weights. As I've said before, using 5 line weights would be ideal on any drawing. If you get 5 line weights, your drawing's pretty good, generally speaking. So if we look at this particular drawing, you can again see the things that are thickest are coming out in front. And it's kind of an interesting holdover. We talk a lot in the graphic design portion about hierarchy. Same thing happens in architectural drawings. We want a hierarchy of these line weights. So the thickest line is right here. That's line 1. Next thickest line is this balcony right here that's coming out towards us. That would be line thickness 2. Next thickest would be the border that goes up and over and back down here. That would be line thickness 3. Then we move into kind of an intermediate set of lines. It's probably the textures on the wall. Maybe that's 4. Maybe it's the windows. They're kind of in the same ballpark. And then we get to this on the side, which is maybe 5. So there's our 5 line weights as we go back. When we move on to the next one, and again I'm showing you these examples in a variety of contexts, the same things apply. Some architects like to show shadows. and they really emphasize the shadows. In this case, there's a lot of shadow. In the last drawing, there was not much shadow. So I go back here. There's a little bit of shadow, but it's light. This shadow here is a much darker, bolder shadow. And that's causing us to read where the overhangs are, what things pop out of the building. That's another way of showing it versus a bunch of line weights. So this drawing probably has fewer line weights in it because the shadows take the place of a line weight. But we're still getting a pretty good sense of what's popping out towards us based on those two factors. In this example, they've filled in the ground, so it's instead of being white underneath, it's the gray that is underneath. Again, the thickest line is what's cut through, and the thinner lines are the smaller details and the things that are further away. The trees and the brick being the smallest, thinnest lines. I like this progression because it shows a little bit of where we're going in the class, in that we have a building elevation that is just a nice line drawing. And then as we start to move it into a production drawing or something that we want to go on in an architectural presentation where we want to draw a lot of attention to it, we might start to do much more collage work where we're showing textures, wood grains. In this case, they're showing a day version and a night version of the same elevation. So that's a lot more collage. That's using Illustrator, that's using Photoshop. So it's a combination of the line drawing being good to begin with, and then starting to work through the collage to bring out certain elements. And we'll talk through that, and I'll teach you that later on in the semester. These particular elevations, to me, don't have as rich of a set of line weights. They're a little bit more stark. If you look at the lines of the roof plane, for example, they're a little heavy. They don't need to be that heavy. They draw too much emphasis to the roof and or too much emphasis to the shadows. There could be more diversity in these line weights. And I think that would make it a little bit better as a drawing. Another example here of a couple more building elevations. Like I said, I'm just starting to flip through and show you these so that you're thinking building elevation as we go forward. The textures tend to be the lightest, thinnest elements of all. More complicated elevation, much bigger than what you're drawing right now. This is actually a plan, but it was so pretty I had to include it. Sorry. Another example. This is a little bit more of a technical drawing where we're seeing more notes involved. I included this because of the leaders. You can see the leaders and the fonts, but we're also cutting through a few things like the deck, and so we're seeing little textures for the deck and that sort of thing. We're not going to be doing section drawings in AutoCAD in this class. So we will do sections when we get to SketchUp, but we're not going to do section drawings in AutoCAD. Though it may be something that you'll have to do in studios a little bit later on. And sometimes you get into the line drawing being fully collaged. And so something like this is a very nice, almost a rendering of what's happening in this building. It's actually partially an elevation and partially a section. So I'm cheating a little bit because I'm showing you section as part of it. But you can see that it's really tastefully done. The colors are light, but the line weights still exist. There's still a hierarchy in those line weights. But they are emphasizing a little bit more with the colors, and your eyes are drawn to those as well. Another example here, I think this one's pretty clean, and it's pretty easy to see the difference in the line weights. One of the things that I want to point out about this particular drawing is the way that they've changed the texture. So in this piece of the building right here that's coming toward us, all the lines and the textures are black. And when we step back to this section of the building or to this section of the building, the textures have turned to a dark gray versus being a true black anymore. So they haven't gotten any thinner, they've just gotten lighter in their color. So that's another trick that you can use. In this case, I would say that the texture is 0.00 millimeters in AutoCAD, but this would be BLK or black. This one is probably, I don't know, a 251 gray or something like that. If my memory serves me correctly. It's still a 0.00 in thickness. But it looks further away because of the shift to the gray versus the shift to the black. These have a little bit more shadow on them, so you're seeing the emphasis of what pieces are popping out towards you. You don't need the shadow to show what pops out, but sometimes it's helpful to do the shadow. The shadows are a little bit tricky unless you've gone through and technically understand how to construct the shadows. The other thing that I find very amusing is that architects love shadows so much that half the time they don't pay attention to what face of the buildings they're on, and they just put the shadows in anyway. And so if you see all the building elevations, they all have shadows on them, where in reality, the north side of the building isn't going to have shadows because of the way, or the whole building, the whole north side of the building will be in shadow. So you won't see the shadows, if that makes sense. So it's one of those kind of amusing things when you look at architectural drawings, but it does show the depth really well. So I'm going to end with 3 slides. This is the project that I'm currently building in Lafayette right now. They're all the same elevation. This is the front unit that's on the street of this little development. And this was the design review drawing that I showed to sell the project to the Design Review Commission. This is what it looked like. It doesn't have any superfluous information on it. No notes or anything. It just says Unit A, front elevation, here's the scale. And I did put some color on it so that they could see this is kind of the intended color of what we're going to end up making the building. Now, of course, things change, like the front door doesn't look like that anymore. And things evolve. But this is the drawing that I showed to try to sell the idea. So then I needed a little bit more technical drawing. After I gave them the idea and they said, yeah, okay, it looks pretty good, let me get a little bit more information. So here's the next set. This is still in the design phase, so nothing is really technical yet. But I'm pointing out certain things like window trim, see detail on sheet 25. Unit A siding is going to be this Cedar Valley single siding system. I'm giving a few finished floor elevations. So it's a little bit more technical information as you go forward. Then you move into the actual construction drawings. And you can see the shift. So that first one, we had all the color. Then we moved into the second one, and the color went away, and it was a little bit more technical. The line weights were still very strong. Things that were forward ended up being more bold. Things that were further away got lighter. I think the easiest thing to see here is the shingle pattern. From the front face to the next step back is a different line weight and a different color. Then you move into the technical drawing, this is how we're going to build the building drawing. And you see that the line weights are still there, but they're much more downplayed. The shadows are gone altogether. And this becomes a technical drawing about what's the finished floor heights. Look at all the details that I'm calling out. This is how I want you to flash the roof to wall. This is how I want to construct the head of the window. That's what all of this, all of these at the bottom refer to details that are on other sheets in the packet. So you can see that this becomes a much more technical drawing. And so all 3 are classified as building elevations, but I wanted to show you the difference depending on your intent of how you might show the building elevation. So let's move on from here. I'll leave you with some parting wisdom, however, and that is that if you want to get good at drawing, the single biggest thing you can do is to get good at line weights. The best sketches out there have good line weights. The best drawings out there have good line weights. So if you practice with your line weights, you will become a good drawer. So let's move on, and I'm going to show you how to construct the elevations based on the floor plan that you have. My guess is that you haven't actually spent that much time thinking about the elevation of your building yet. So this is going to be entertaining today for you to figure out how it really works beyond just the plan. So give me a second to switch over, and then we'll start drawing our elevations. Okay, so I went ahead and I pulled up the same floor plan that I had from our last class that I had finished up with the hatches on it and what have you. And I'm going to start by thinking about the south elevation. And so as I said before, this drawing was set up so that north was up, south was down. So the south elevation is this side of the building. And so when we draw a building elevation, essentially what we're drawing is we're pretending as if there was a flat sheet of paper that ran right along the outermost, or in this case, the southernmost edge of our building. So if I had a really long line that went like that on both sides, when I draw the building elevation, I'm drawing it straight on that surface as I look through it. And so when we start to set this up, I can use the floor plan as a guide for how I'm drawing the building's elevation. And I'm going to draw this building's elevation directly below it right here. So before I begin, though, I'm going to go into my layer properties. I could type layer also to get the layer properties. And I'm going to create two new layers. The first layer is going to be A-south elevation. Some people choose just to make it an elevation. And for right now, I'm going to change the south elevation layer to have all of it to have a line weight of 0.2 because it was currently set at 0.4. Then I'm going to create one more layer. And this one is going to be a layer called guides. And so this guides layer, I'm going to come over and I'm going to click on the printer icon to make sure it doesn't print long term. And I'm also going to change the color of the guides layer. And so instead of being white, I'll pick red or magenta or blue or whatever. I think red shows up fairly well on the screen. We're going to try. I'm going to pick my color based on what looks good on the projector. So I'll try red as my color. So it's a non-printing red layer. I'm going to set my line weight to 0.00 because I don't need to see any line weight on this set. And I'm also going to set the guides layer as the current layer. So I will double click on the little parallelogram on the side where it says next to guides, and that green check mark will move down on the guides layer. That means anything that I draw right now is going to be on the guides layer. And so with that active, I'll go ahead and close my layer properties manager. There it is. And I'm going to start to work with this building elevation. So first thing I'll do, I'm going to set up a few guides that pull down from the major corners of my building. And I have two options. One, I could come up to the line tool, I could snap to the corner, and I could draw a line that goes straight down. The other thing that I can do is I can use something called array. And so I can type in ray, or I think it's hidden underneath here. Yep, right there is ray. And what array does is it starts at a given point. It asks me for that point, and then it asks me for a direction. So I want to go straight down, and when I hit enter, it just goes off into infinity. It's kind of like a guideline in Photoshop or Illustrator. So I have that ray going straight down. I'm going to repeat the ray command. I'll just type ray this time. And I'm going to go off of this corner of the building and go straight down. I hit enter when I finish. I'll move to the next corner of the building, which would be right here. This corner back here lines up with this corner, so I'm not creating a second point there. I would go from this corner down.
Can you change the color?
Oh yeah, you guys can't see it at all. Sorry about that. Thank you for telling me. I thought red would show. Can you tell the difference between that and white? Is that good enough? Let me see. No. Good old projectors, right? No. Definitely not. You can kind of see the green. I'll leave it as green. I don't like using green because I tend to use it later on as something specific, but it's okay. We'll use green because you can see it on the projector a little bit better. So I apologize that the projector is the way it is. OK, so let me continue with my rays. I'll type ray again, and I'll go from this corner of the building. So I always start with the major corners. And one of the temptations, once you get the system of what I'm doing, is to draw rays from everything all at once. And if you do it that way, you're going to get confused as to what's going on a building facade. So keep it simple, delete them, make more as you need them. So I have these rays going down. I'm going to also create an arbitrary line that goes across all of these to set up the base floor of my building. And this time, instead of using a ray, I'm going to use something called an X line, which is a construction line. It's basically a two-sided ray. It goes in both directions instead of one. So I'll click on the construction line or type X line into the command line. And I'll start that, and I can pick any place down here. I just want it to be going perfectly horizontal. And there it is. So this line here is going to represent the floor of my building. And we'll deal with how we get to the ground a little bit later. But we're going to start as if this is the floor. And so what I need to know is I need to know the heights of these walls. Typical height would be 8 feet. Something that's vaulted is going to be a little bit taller than that. You're the designer. You have to pick somewhere larger than 8 feet is what I would specify. In my case, this building I had designed actually has a flat roof on it. So I will draw one of the elevations with a flat roof. I'll draw this one with a flat roof. And then when I move over, I will draw the opposite elevation with a sloped roof, even though it doesn't technically match, just so you can see how I would draw the slope roof. So I'll do it both ways. So this first one, I need to actually start drawing in my elevation using these as general guides. So I'm going to move up into my layers, and I'm going to switch from my guides layer into my south elevation layer temporarily. And I'll go ahead and start with either the Polyline tool or the line tool, either one. And I will start right at the base there, and I will draw up however tall my first wall is going to be. So in my case, on this side, it's going to be 12 feet. So I'll draw 12 feet up, and I'll come over, and I'll draw 12 feet down, like that. So these lines that are selected right there then represent the first kind of box of my building. That's one piece of my building. Then it steps back into this part, the little bridge of my building, in between this wing and that wing. And so when I draw that, I want that to be a little bit shorter. So I might come up to maybe 9 feet here. So you could start here, or I could use my tracking and come up 9 feet, draw over to right there, and draw back down, like that. This last piece is going to be a little bit taller, so it would be 16 feet. So I'll start here. I'll go up to 16 feet. I'll go over, and I'll come back down. And actually, I think I did these reversed because that's the bedroom. This is the one that should have been 16 feet. So let me move that up by 4 feet. And I'll move this one down by 4 feet. Make sure that these lines get a little bit shorter. These lines get a little bit taller. And so for clarity for you guys, when I'm drawing, I don't see, I can completely ignore that topo line. I don't even see that it's there. To make it a little bit easier for you, I am going to temporarily turn off the topography just so that you can concentrate on what you're seeing. And so you can start to see now that I have the basic massing of what's happening in this building just by pulling those lines down. At this point, I could leave these lines, or I could come through and get all of these guides and press the delete key and get rid of them. There's some other things that are happening. So in this, for example, the walls extend beyond the plane of where the windows are, and there's a little overhang that happens. So I would need to come over here and draw that down here. So once again, I can use the rays to find out where it is. I'm going to switch to my guides layer. I will select ray from the toolbar, or type ray, and I'll pick the inside wall there. I'll repeat my ray and select the inside of that wall. And then I can draw a line that goes up. Oh, I should switch into my south elevation first. And I'll draw a line that goes up. I'll say that there's a foot of roof up above here. So I'll draw this line at 11 feet. And I'll come across, and I'll come back down like that. And so that's then identifying the wall that's sticking out right here, and the wall that's sticking out there, and the overhang that comes across the top right there. If I move to this wall, what I have is a series of windows and nothing else. So I will use the ray command again. And again, I'll switch back into my guides layer. And I'll use the ray command. And I'll identify where one of these windows would be. So there's one, and there's two. These windows are all above where the kitchen countertop would be. So they're going to be about 48 inches from the ground, because a kitchen counter would be 36, and I want maybe another foot before those windows start with where my sink is. So when I go to draw those, I will again start with my line, but I have to switch back to the south elevation layer. I'll start with my line tool. I will come up by 4 feet or 48 inches. I'll draw over, and then I have to draw the window itself. This window is probably a fairly tall window, so maybe it's a 9-foot window because the ceilings are really tall. I'll come over. This obviously would be a very custom window, and I'll draw that first window in. It probably wouldn't hurt for me to add some depth to the window so that it's not just a basic box. Maybe there's a window frame that goes inside if this were a fixed window. So I could select all of these. I could join them together by typing join. And then I could offset those by maybe 1.5 inches to the inside to create that frame. If I wanted to, I could also divide this window. Let me turn on my midpoint snap. There it is, midpoint. I could come up here. I could offset this. It would be 0.75. Delete the middle. And you can see that I'm starting to create that tall, skinny window. Once I have this window in place, I don't need to redraw it for each of these because they're all the same. I can select it, and I can come up here and type copy, or select copy from right there. Pick one corner of this window, and then just copy it on each of these windows as I go over. And you'll see that it's just creating the copy down below for me. And suddenly I have all of those windows. So I spent the time drawing the detail on the window first, and then when I copied and pasted it, it was really easy because it was already drawn once. So I'm only drawing that window one time. When I'm done, I would select those rays, maybe these rays too, and I go ahead and delete those. So I have those windows drawn. Here, I have a post in the center, and I have 2 sets of windows. So same thing, I would type ray. And whoops, this was not on the guides layer. There it is. And we could go back to the guides layer. I typically delete these rays after I've used them because it can get rather cluttered when you have lots of these rays coming down. So if you stay clean without too many of them, that can really help. So in this case, I'm going to go down. Let me switch to my south elevation. I'll go down by 1 foot. And there's one window. There's the other window. And these are in the bathroom, so I'll do them at 48 inches as well. Now, why there would be a full window in the shower, I'm not quite sure, but I drew it that way, so it is what it is. And so I could continue to develop those windows. Let me delete these rays so you can start to see them. I could continue to develop those windows a little bit further. I could add the frames, etc. Likewise, this wall here is a curtain wall with lots of tall windows and little divisions. So same thing. I could use a ray there and there. And I could come down and draw the style in between the curtain wall windows. And then I could take them and I could copy them where each of those divisions happen. And then I could add more detail like the cross divisions of the windows. You can use these windows as an example. You don't typically have the full height glass. You usually have some kind of a division somewhere. So putting a division in would make sense. So at this point, I've drawn essentially the basics of a building elevation. You guys are going to spend a little bit more time and really refine your elevations and understand what's happening. But we are going to draw all 4 elevations, or attempt to do that today. But I want to talk about a few other things, and that is at the bottom here, we did it as if that was the floor of the building. Well, typically speaking, that's not the ground of a building. The building extends beyond where the floor is. So if you walk into your house at home, assuming it's ground level and not a second-story apartment, typically you step up a couple steps to get into your house. That's normal. Underneath your house is some space. And this is again typical of most California construction. Sometimes, technically speaking, it's on a slab, which changes just a little bit, but generally the dirt is down a little bit from wherever your entry would be. So we're going to call that plane, this line, where the finished floor would be. And I'm going to suggest that you come in and you draw a foot down and across to represent the structure of the building. And my building gets a little weird because it has these little wing walls sticking out. Like that. And then below this, I would encourage you to use the ground plane at 8 inches below where that is. So I'm going finished floor down a foot to end the building, and then another 8 inches down before the ground happens. And that's because you typically have a little bit of foundation outside of your building. This building is technically on a slope, so the ground should technically slope. I'm going to show you guys today, for those of you that feel advanced enough to follow along, I'm going to show you how you calculate out what the slope would be based on the topography. If that goes over your head, just draw a straight line, and I'm perfectly okay with that. Whenever you have a class like this, sometimes people are more advanced in AutoCAD and they want the challenge. Sometimes they're just trying to pedal enough to keep up, in which case they don't need the extra challenge. So I'm going to try to show you both today. So let me continue and finish this as if it were flat on flat ground. Let me copy this. I'm going to go down a foot for the bottom of the building, and then I'm going to go down another 8 inches to represent where the ground would be. That's the ground. Typically, there's a little bit of a reveal between the edge of the building and the foundation, so I might come over by a 1/2 inch or 3/4 of an inch before I draw the foundation of my building. That. These ones here would just keep going all the way to the ground. Like that. And now, if I was to temporarily get rid of these, actually, let me draw the ground in first. One more line. Ground typically extends beyond both sides of your building. And remember that ground line is the thickest line of all. So I'm going to select it and manually, not based on my layer, but I'm going to come up to my properties here. I'm going to go to my line weights, and I'm going to say that's going to be nice and thick, and we'll do it maybe 0.7. So it's a nice, thick, bold line. Once I have that done, I will select these guides, and I can actually delete them. And we get what the bottom of my building looks like. Looks like I need a few more little lines here to represent the bottom of those windows. And I'm going to trim out those little pieces in there to represent that side of the building. And so I was able to create this elevation using the floor plan as a guide to create it. So I'll come back and I'll do the slope and I'll show you guys how to do the slope. Yeah?
So, you know how you have the small indent on the left side? How come the same things on the right side and the bottom?
This here?
Yeah.
I have this indent because in typical construction, there would be some kind of a siding on this building, and that would extend beyond the plane of where the foundation is.
Okay,
This Oh, right here is what you're asking.
Yeah, why would you have one all around the other?
On these ones?
Yeah, right.
So on this one, the way I had drawn it, well, I guess I could have had it. It depends a little on the material. And so I was envisioning this as being kind of a concrete shell, separate, this being a wood texture. I'm sorry I didn't explain that well enough. So the one other thing that I could add is I could use my hatch tool. Remember we did hatches last class. I could use my angle. I'm probably going to have to change my scale, say like this. And I could set my angle here to be at 45. There we go. To be vertical. Or maybe I want it to be at negative 45, so it would be horizontal to represent the siding of that particular piece. I also want to go through and change my lines. Things that come toward me need to be bolder. So in elevation form, I actually recommend just going around and assigning lines weights manually. Because typically it doesn't fall cleanly into, you have everything on an elevation layer and that's it. So I would go through and I would say, this is coming toward me, therefore it should be maybe 0.3. This piece over here is a little bit, even a little bit closer to me. And so as a result, I might make that one 0.35 or 0.4, something like that. And then these pieces back here are a little bit further away, so they might be at 0.2. And we could start to see the depth appear out of that. The horizontal siding here, I would change and make sure that was at 0.00. I might even change the color. So right now it's by layer. I might even change the color to be maybe 251. That was the color I was telling you about earlier, which is kind of a light grayish color, which makes the siding fade away a little bit. It's hard to see it on the projector, but when you actually go to print, it can make a difference. So before I get too far involved here, I am going to show you what if you wanted to do a peaked roof instead of a flat roof, because I want to show you the process of doing that, because it's a little bit different. And with all of these, we need to draw all 4 of the elevations at once. So for me, I have a lot of practice drawing elevations. I have a lot of practice drawing in general. I don't have to do anything. I could draw the building elevation, in this case the north elevation, upside down, and it doesn't make any difference. My brain works that way. Likewise, I could draw the building elevation here, the east side elevation, I could draw sideways, and that would be fine. That takes a lot of practice and training mentally. AutoCAD enabled some stuff that makes our life a whole lot easier, and that is right over here in this kind of compass setup. If you hover over the compass in the upper right corner, there's a rotate view button, these 2 little arrows, and we can actually rotate our view around such that now the north elevation is down, and you can draw the north elevation from here. Before I actually do that, though, I want to show you the relationship among all of these building elevations. So we went ahead and we drew this to start. But if I were to create a bounding box around my overall building elevation, and what I mean by a bounding box is completely contain my building inside of a rectangle. So I'd start at that corner. This would be the outermost point along here. This would be the outermost point along there. I would have a rectangle that looked like that. That would be my bounding box. If I were to have that bounding box, and I were then to have a 45-degree line extending from each corner, I could use the heights here to draw the elevation there. And this is a little bit more of an advanced topic, but I want to point it out to you right now. So let me switch to my guides layer, and let me draw that line. I'm going to go back to Array. I'm going to start at this corner. And when I go to draw this, I want it to be at 45 degrees. So I'm going to hit the Tab key to switch from length to degree, and then I'll type in -45 and hit Tab again. When I'm done, I'm just going to click the mouse, and it's going to create that line at 45 degrees from this point. I can do that again just for practice. I'll go to ray, I'll go to this corner, and this time instead of negative 45 it would be positive 45. There it is, and I'll click the mouse without moving it. That then creates that ray. I'll do the same thing off of the other corners of the bounding box. So ray from right there. This would be at 135. I'll click. And I will repeat the ray from right here. You have to make sure that it's the corners of the bounding box, though. If I were to move this up to a different point, it wouldn't work. So it has to be the corners of the bounding box. Once again, I'll hit tab. And this time it was negative 135. And I'll click. That gives me all 4 of those reflecting lines. So at this point, I can start to pull lines around. So I'm going to draw this side elevation because it's really easy. This is the most simple elevation of my whole drawing. So let me rotate my view. Oops, sorry, wrong direction. So I can have the east side facing down. There it is. I will work with my rays. I'll type ray. I'll start at my ground plane. And this would be my ground plane here. So where that intersects here is where I'm going to start drawing at the ground plane. So let me do a construction line there, which just goes in both directions. There it is. Then I'll pull down my finished floor. So ray. There's my finished floor. And there's my finished floor. I'll go back to ray, and I'll pull down my corners of my building there and there. And the next thing would be the height of this building. So I can go from the ground all the way to the height here. Ray, down, and then construction line there to there. And essentially, I've outlined where this building goes right there with those boxes. So I'll switch over to my south elevation layer. And actually, I should create a new layer for east elevation. So A-east elevation. We'll make the east elevation current. And then I'll go ahead and draw in. This comes up to there. This goes over to there. This comes down to there. Like I said, easiest one for me to do. It's basically a box. I need the ground plane still. So I'll do a line. We'll come over like that. I'll select that line. And oops, sorry. This needs to be nice and thick. So we did it at 0.7. And there's my ground plane for my building. I could add a few more little details, like the fact that this goes in and then down. I could do a hidden line with that. So I could come down by a foot. I could go in until I matched where that corner was, which I really should have done a ray from there. Move there. And there. These should have been on the guides layer. There we go. Now I could go in. I could come down a foot, over and down. That represents the face of that building in the inside. Likewise here, I could come down a foot, come over, and all the way down to right there. Now, since those two are hidden, they're not seen, I should change the line type to hidden. So I'll select each of those, there and there, and I'll come up and first change the line weight to 0.00, and then change the line type to hidden. Well, hidden isn't showing right now, so let me click on Other. Let me click on Load, and I'm going to use the Hidden To line type. And sorry, I have to go back and select those again. And I'll change those to Hidden To. They won't show up right now because I'm not in Paperspace. We'll get to that scaling, but I have gone ahead and done that. A few other things. One, I'd see this building over here behind this. So I need to do one more set of rays. So I do a ray. Whoops, let me switch to my guides layer again. I'll type in ray. We'll come down. We'll do an X line and go across. That's then the height of this building. Then I need a couple more rays that come down there. And that come down right there. And so here's an example where I'm starting to get too many rays. Now, which one is the one that is the building? So sometimes you need to clarify and get rid of a few of the lines. And now this, up, over, and back down, is going to represent that other part of the building. So I'll draw up. Oops. I need to be on my east elevation. And I'll go up, over, and back down. And now to make this see, to be able to see it a little bit better, I should take the line weights and change them. So these lines here, not my X line, would be the thickest lines because they're closest to me. So we'll make those at 0.4, for example. And these lines up here are much further away, so they would be at maybe 0.20, 0.25, something like that, because they're further away as I start to create these. The alcoves are both hidden lines, and they're nice and thin. So I've drawn this elevation. I've drawn this elevation. I should probably hatch this one back here to match that hatch because it was a different material. So I'll go back to hatch, and I'll pick it. In this particular one, it's going vertically. I wanted it to go horizontal, so I'd have to go back to 45 so that it was going horizontal. And this is much further back, so it probably belongs even lighter in color. So we'll do a 0.00 again, and we will also say that its color, instead of maybe 251, it's like 252, so it's even lighter behind. And now I've drawn that building elevation. Again, that was a really simple elevation. So like I said, sometimes you're going to want to do a peaked roof. So the next one that I'm going to do will be a peaked roof. I'm going to flip my way around into the the north elevation. So we'll keep rotating the view around until I get to the north. And then once again, I'll pull some more construction lines. So let me move myself to the guides layer. And I will do an X line or a construction line for the ground first, then the finished floor, and then this would be the top of this part of the building, and this would be the top of that part of the building. Then I would pull my rays down, one on each of the major corners. There's one, there's two, there's three, and there's four. Oh, one more right there would be five. And then I have to draw the building itself. So let me switch back onto a new layer, and this would be the north elevation. I'll call this north. Sorry, before I do that, I'm going to make the south elevation active and then create a new one so it inherits the properties of the south elevation. So this is A-north elevation. We'll make that current. And here's where doing the slope of the roof starts to matter. So if I understand that this piece of the roof has a slope to it and a pitch, I need to understand what that slope is. And roofs are typically designated by rise over run. So when we talk about a 6 and 12 roof, it would be for every 6 inches of rise, you're going 12 inches of run. So you're going 12 inches over. So if I were drawing a 6 and 12 roof, here's a perfect opportunity to use my absolute coordinates, because I don't know what angle a 6 and 12 is. I could calculate it. I would go ahead and type in at 12 feet, comma, 6 feet. So I'm going over 12 feet and up 6 feet. And when I do that, I get the 6 and 12 slope of the roof. Likewise, if I wanted a 12 and 12 slope, so it would be steeper, I would hit tab, or excuse me, never mind. I would hit the @ sign and then 12 feet, comma, 12 feet, and hit enter. And that would give me the 12 and 12 roof. Oops, I went the wrong direction with it. And that would give me the 12 and 12. Does that start to make sense? So I need to know in this building what I want the roof to look like. This is up in snow country, so in all reality, it would probably be a steep roof. So I'll use a 12 and 12 for right now. So I'm going to start at where I think the top of the roof would be. So in this case, it would be right here. This was the taller section of my roof. I would start right there at that corner, and I would say at 12, or yeah, 12 feet, comma, 12 feet, and hit enter. How that keeps doing it negative, I don't know. Let me try it one more time. At 12 feet, comma, 12 feet. Oh, it's doing it negative because I've rotated the view. That's why. My x and y's are backwards. See down here, my x and y's? So it's going that direction. It would actually be at negative 12 feet, comma, negative 12 feet. Now it's going in the right direction. So that's one side. I need the same line right here going up that way. So I'll start right there, and I'm going up that way. So this would be at 12 feet, comma, negative 12 feet. And that gives me that. These two need to meet at the peak, so I could use a trim, for example, to get rid of this and that. And so you can see how I'm starting to create this peak to the roof. Likewise, the edges of my building would be coming down here and would be coming down there. Same thing applies where I'd go another foot down, 1 foot. I'd come over and go back up. And then 2 more little lines that are over maybe 3/4 of an inch and come down to right there. That's a technical detail that just makes your drawing look more realistic. It gives the impression that you actually know that a building is constructed of materials. So there it is in terms of that setup where I have the peak to the roof. Now typically there's some thickness to the roof that's given. And I can choose to go down or I can choose to go up with that thickness. It doesn't really matter. And so I might do an offset here of whatever the thickness of that would be. Again, we're sticking with generic dimensions. So I'll say 1 foot there and maybe 1 foot there. And that's giving some thickness to the roof. The other thing that happens is sometimes you want the building to have an overhang. So it's not right at a corner like this. Sometimes you want that to extend out past your building a little bit. In that case, give yourself a guide, or I already have one here. I'm going to offset that guide by however far I want the overhang to be. So we'll say 1 foot. There it is. Same thing on this side, 1 foot. And then I can use the opposite of a trim. I can use the extend command to extend this line to meet that line. So I'll type in extend, or I can type in trim and hold down shift. Extend is underneath the trim command. And it's going to ask me select objects or select all. So I'll select my objects. And then when I hover over these, it will extend those over to make the overhang. So there I am. I have my overhang. I can finish off that overhang with a vertical line and a vertical line. I can also trim these 2 lines. And for illustration purposes, I'm going to temporarily turn off my guides layer so that you can see what I was creating. See how I was able to create that? This is kind of the generic house look, but you guys get the idea. I could then go in and trim a little bit more. I could trim out this line and this line. Sometimes people like not to have this style of a roof, but they like to have a roof that comes down perpendicular, in which case I could turn on my perpendicular snap. like that, and cut the roof that way. I could also move this down and have a longer overhang and extend this out to meet that like that. It's just a different look, and so you can see it there, this look versus that look. And it's again dependent on your desire for it. If you wanted to add extra trim, if you wanted to make it look a little bit beefier, you could offset this again. I don't know, let's do 9 1/4. And we could add an extra little bit of trim. And let me offset. And I'm just showing you this as an example. It is not necessary that you do it. It just gives you a little bit more texture to the building itself. And so you could do something like that if you wanted to. Obviously, you'd have to add windows and that sort of thing. I'm not overly emphasizing this and keeping drawing because you don't need to see me keep drawing and drawing and drawing and drawing. Okay? You can, of course, hatch. Oops. I am, by the way, because I want to match this set of properties, I'm going to click on this Match Properties button to match the properties of this and put it down here for that, which sometimes is a good strategy once you already have a hatch the way you want. Obviously, this doesn't have any windows on it, but you're getting the sense of what I'm trying to do. So I need the baseline again, so let me turn back on my guides. And I would come in here and I would draw the ground. And I would make that the thickest line. So it would come up here again to 0.7. And then I'd have a nice thick line. In all reality, since this is popping out toward me, I need to select it and make it another line weight. But this is repetitive of the same kinds of things that I've been doing. So the last thing that I'm going to show you today before I completely turn you loose is how to do the slope, should you want to do the slope. And like I said, this is an advanced topic for people that feel really comfortable in AutoCAD and want a challenge, in which case I'm going to show it to you. If you don't feel like it, just go ahead and start working and you can ignore what I'm about to say. You can just do the flat lines and that's perfectly reasonable. So I'm going to switch back into my south elevation. And I'm going to turn off my current guides and I'm going to create another layer for another set of guides. And I think I'll call this one Topo Guides. I can't even type. Once again, it's going to be a non-printing layer. The color, I'm again going to choose green. I wonder if orange would show up for you. We'll try orange and see if it shows up on there. And let me turn that Topo Guides layer on. And also, to be able to do the topography, I need the topography itself to be turned back on. So there it is. I also need to go ahead and delete the ground planes that I had already done. So there and there. And there for that matter. I will delete these. Okay, and so now it's time to start figuring out where that, what that slope would be. Remember, all of this is going downhill that direction. And that's important to know which direction is downhill. So it's going down that way. So as I said, the elevation is taken on a plane that is right in line with this face of the building. So with the Topo Guides layer on, I'm going to do a construction line, an X line, that goes right along the face of the building, right? It would help if I could snap to the building. There we go. That goes right along there. Yeah, you can't really see it. Let me change the Topo Guides color. Like I said, I was avoiding green, but it looks like green is the only one you guys can see, so that's what you get. Okay, so that's right along the face of the building. The next thing that I'm going to do is I'm going to find every point that this crosses, this line that I just drew, crosses the topography. And I want to have enough space, so I'll probably start at this point, I'll do this one, I'll do this one, and I'll end at that one. So there's 4 of them total. And I'll create a ray. First one will be there. Second one will be right there. Third one will be right here. And the fourth one will be right there. And so I created an array at each point that this plane crosses the topography. So 1, 2, 3, and 4. Now down here, and I'll end up moving it up to my elevation in a second, I'm going to create an X line, or a construction line. Again, one that goes in both directions, right there. Now each topo line, I told you, goes up by 1 foot. So I need to offset this construction line by 1 foot. So there's 1, there's 2, and there's 3, and there's 4. So then I can create a curving line that starts at its highest point here and goes down at each one of these points. To do that in a smooth line, I'm going to use something called a spline. It's this one right here. It's called a spline fit, or if you just type spline, it will get you there. But before I do that, I want to switch over to the south elevation layer. And so that this becomes really obvious, I'm going to go ahead and change my thickness ahead of time, so you can see it as I create it. So I'll pick the spline tool right here, or type spline. I'll start at that first point, the highest point, and I'll come to the next point. I'll go 1 down. There's the first. There's the second. And there's the third. I didn't go another topo line, so I can end right there. I'll press the Enter key, and that then gives me the slope along the back side of my house. I'm going to move this up to meet that first 8-inch point right there. So I can create a ray that goes from right there down. This should be on the the topo guides layer, and needs to not have thickness. I will take this. The reason I created that guide is so that I can move it directly from the intersection of those 2 lines. And we'll come up to where I meet that point. I now have the slope of the ground as it goes across my building. It's subtle. It's not a big slope. It's not a super steep site, but that's how I would create that. So I'm going to need to extend. Again, it's the opposite of the trim. It's the extend. I'm going to need to extend all of those little short lines down to meet the ground. This is way longer than I need for my building elevation, so ultimately I can use these 2 rays to trim and get rid of that and that, which leaves me just with this nice little piece of terrain. So I created it for this first side. I would then need to move around and do it for each of the other sides. So I'll again stick on the topo guides layer. And we can delete these, delete these. And for the next building elevation, when I rotate my building, I'll create a line that goes along this face. So once again, it'll be an X line. Like that. Oops. Sorry, I should have been on the guides layer first. And there it is. That's the plane. I need to identify the intersections. So once again, I will go to my ray command. Oops, didn't quite get that. Oops, ray. Okay, so same process, X line. It would help if it was straight. and offset at a foot. And then this would be on the east elevation. It is spline starting there, down 1, down 2, and down 3. And that then gives me the slope along this edge. The only critical part here, though, is that I need to know where this intersects the building. And I can do that by following around where this corner hits. And so I'll use that 45-degree line that I had in my previous guides right there to pull that line over. So let me clean these up just a little bit. I'll do a ray from right there now, which is at slope. Oops. Sorry, this should have been on the guides layer. And where that intersects the 45-degree line is right here. So one more ray starting right there. And again, that should have been on guides. And now I can move this line up at the corner of the building to where it meets that line there. So one more ray. And I will move this up to where it meets right there. That then is the slope along this side going down. So this would once again need to be set at my 0.7, and then all of these would need to extend to meet it. Oops, sorry. And all of those would extend, and now I'd have that slope on this side. So like I said, it's an advanced topic to do it. It's not required as part of your assignment. You just need the flat. That's all that's required. But if you want to try to do it and actually calculate what the slope is, that would be technically how you would figure out what the slope is along the sides of your building. Your building will look more realistic with a little bit of slope, but again, not required as part of the assignment. So for the rest of the day, you're going to be working on your elevations. Start with the south elevation and then move into the east, west, and north elevations. Think about what I said relating to line weights and making sure you specify your line weights. If you haven't finished your floor plan yet, now would be a good time to finish that floor plan, get the line weights kind of set up. Next class, we're going to talk about model space and paper space and actually scaling drawings and getting ready to print, etc. When it comes to turning something in today, do a publish to web JPEG of at least one of the elevations. You don't have to show me all of them. Just show me that you did one of them. Yep. OK, I'm coming over after. OK, so unless there's questions for everybody, I'm going to stop, and then I'll come around and help you guys individually.